Yeah, but this is a slightly tricky thing. Would you go in for a 100 or 200 or 300 meter deep site when there is the possibility of a deeper site? And right now, I should say that we have found at least two places, one almost certainly, which will give us a height or which will give us an overburden of something like 1.8 kilometers. So that's a big improvement on the Theni site, which was about 1.27 kilometers.
So I think the main background is muon you can tap them, but the muon which is not going through your detector, missing the detector but producing neutral electron which is coming inside your detector and producing electron, that's the main background. And that is quite large even at shallow depth.
But I wasn't aware that you have alternative deep sites. So
Alright, now they are looking at it. Any more question? Yeah, there is a question.
So I was wondering, is the muon veto of potential interest for the Gran Sasso lab, which is deep but not so deep?
I mean, it could be of interest. By the way, I should say that although we thought of it and we didn't know anybody else who might be doing such a thing, after we got this result, then we looked up the web, and mu2e in fact has exactly that specification. 99.99% efficiency for cosmic muon, so that they can veto events in the detector, and that improves the sensitivity to 3 orders or 4 orders of magnitude. So in principle they are far ahead. If something like that would have to be done, maybe they have to talk to these guys. We are still in the process of building a small veto. Of course it's much bigger than what we built, but I think we realized at that time that they were already building it, and then we got in touch with them and they provided us some help in building this one as well.
Yes, sir.
Yeah.
I have two questions.
Yeah.
The first one is whether this CP violation that this Super K people have observed, does it not rule out this whether neutrino is a Majorana particle? Because if there is
No. That doesn't say anything, I think, about the nature of the particle. That is something that neutrino-less double beta decay experiments will definitively say whether it's in R or not. There are also other ideas, and one of my colleagues, in fact, has an idea, which is very general, apparently, just on statistics, post-Einstein. So anyway, but especially neutrino-less double beta decay is the way to answer this
but
question.
since you are saying that since neutrino and antineutrino are behaving differently, so
Yeah.
if they are Majorana, does it not
Yeah,
rule it
but
out?
see, but that has to do with the handedness also. I mean, you can have a difference because the one which is produced in an interaction which is left-handed and right-handed, they can be different. So CP violation is allowed even if it's a Majorana.
And the second question is how hard it is to detect few keV order energy in neutrino?
Oh, very difficult. That's a good question. I mean, see, at least most of the literature on this subject thinks of tritium as a possible candidate for that. In fact, people, not just from the point of view, I don't think they have sensitivity to the cosmic background neutrinos, but for some other exotic things, people, the Catherine collaboration has looked for a monoenergetic peak at the endpoint energy of tritium, 18.6 eV, and have put bounds on that, put number of bounds on that. But yes, if indeed such a thing, if you can make enough of tritium, that's a humongous quantity of tritium that you would need, then in fact you can do the inverse reaction. So it's with the beta decay, you take the neutrino on the left hand side and then you produce a monoenergetic electron. That's how you will detect it. So basically you require something which has a positive Q value in the language of nuclear physics. Because this energy is too low. Most of the things that you could think of will not go through because just energetics. So you have to look at radioactive nuclei in order to get there. And tritium is certainly a possibility, but at this moment the amount of tritium required is so humongous that apart from proposing it, I don't think anybody...
Even the holmium, ECDK of holmium, ECDK of holmium or this dispersion.
Okay, but that's another nucleus which has to be produced. It's not, I think, available in nature. Okay, so just like tritium, you have to produce it, and then you have to produce it in enough quantities. Yeah. So maybe there are other
Okay. Any more question? If not, let's thank Vivek again and follow up on the next